please speak up if you're not sure about something though. Okay, so simplifying rational expressions. All right, the first part is I just want to show you, all right, how simple it is. If I said, for example, 3/6, we all know that's going to reduce down to 1/2. All right, that's basically what we're doing, except we're going to be reducing fractions with variables this time. Now, the first observation you need to remember is it possible to have a 0 in the denominator? All right, or is it possible to have 0 in the numerator? All right, well, let's look at both cases. All right, the first case, remember, would be written like this. And the second case, it would be written like this. All right, this is how I learned to remember where 0 was not allowed. All right, 0 is not allowed in the denominator. All right, the reason it's not allowed in the denominator is because you're supposed to be able to tell me when you do the division what times 0 is 3. Well, there is nothing times 0 that's 3. That's why that's no solution. All right, the one on the right, 0 divided by 3, 0 times 3 is 0, so that's an okay division problem. So 0 in the numerator is okay. 0 in the denominator is not okay. All right, you cannot ever divide by 0. So whenever you're dealing with a fraction, you will understand, or you will know, that I will never ever put a 0 in the denominator. Now, why do we talk about that? We talk about that because when you're dealing with rational expressions, all right, rational expressions imply that there's going to be a variable involved. All right, so all of these things will have variables. All right, now let's look at question number 2. All right, it says in exercise 1 through 12, for what values of the variable is each rational expression undefined? So the key is undefined. So I can make a fraction with any two numbers. The only exception is that the denominator cannot equal 0. So the simple way to do 1 through 12 is we just take a look at the denominator, and in this case, y plus 7, and we say y plus 7 cannot equal 0. And then you just solve it. Subtract 7 from both sides. So we say y cannot equal -7. That's all there is to it. All right? All you have to do is look at the denominator and figure out what will make the denominator 0. That is what makes it undefined. All right? So now I want to look at question number 4. Question number 4, is there a variable in the denominator? And the answer is no. All right? So what we say is that there are no restrictions here. There are no restrictions in question number 4. The reason, because there's no way the denominator can be 0. The denominator is always 4. All right? Now, am I making sense so far, guys? Somebody, you got to speak up, okay, if I'm not clear. All right? Question number 6. All right, again, all we're doing is looking at the denominator. We set the denominator. We say 3x plus 1 cannot equal 0. So then we solve this out. 3x cannot equal -1. Divide by 3. X cannot equal -1/3.
When you get the -1, do you just make the, like one you had before, the opposite sign?
Yeah, exactly right. Because all we're doing is this, kiddo. We're just solving like normal. Subtract 1, subtract 1.
Okay.
Does that make sense? And then we divide by 3.
Mm-hmm.
Okay, good question. All right, is everybody happy?
Number 4 is no restrictions, just the answer. You wouldn't
Yeah, there are no restrictions. There are no values in which the expression is undefined. All right, let's look at number 8. We would just simply say x cannot equal 0. That's it. X cannot equal 0. It's really, really simple, guys, really simple. But a lot of people have a hard time. They don't understand what we're doing, all right? And I try to remind kids, it's all going back to this fact right here, that when you make a fraction, you can never have 0 in the denominator, all right? So let's take a look at number 10, all right? So number 10 would just say cannot equal 0. Add 7, 3x cannot equal 7. X cannot equal 7/3. Everybody good? All right, last one of this lesson. Cannot equal 0. So now I subtract 1/3 from both sides. So 3x cannot equal -1/3. Now I'm going to have to divide by 3, right? So dividing by 3 when you have a fraction is the same as multiplying by 1/3. All right, multiplying by 1/3. And now you should be able to say these guys cancel. So x cannot equal -1/9. Now that was kind of the hard one, okay? Just because it has an extra fraction. All right, does everybody agree? 1 through 12, simple, simple. Just set the denominator equal to 0. That's all you have to do. All right? Now, honestly, I thought this was kind of silly. We don't need a calculator because this is just mental math. All right, it's very simple. Okay, so here we go. Now it says just evaluate. So what does evaluate mean? Evaluate just means plug the number in. Plug the number in for x. So I'm just going to write the whole thing just to make sure everybody understands. I'm just substituting in the 2. So 5 times 2 is 10. 4 times 2 is 8. So evaluating that rational expression would just be 2. Anybody have any questions? All right. 16 is the same thing. We're plugging -2 in for x. Plugging -2 in for x. So 4 times -2 minus 7 over 2 times -2 minus 1. -8 minus 7 over -4 minus 1. -15 over -5, which is +3. All right, so anybody have any questions with that? I told you guys, really simple. All right, now the next part of the lesson is the actual simplifying the rational expression. All right, simplifying again just means reducing the fraction. All right, so we're going to look at number 18. Now, of course, we could use our calculator, type in 45 divided by 75 and reduce the fraction, but that's not necessary for us. All right, the numbers here are always relatively small, okay? So you should be able to say, I know 45 is divisible by 15, and I know 75 is divisible by 15. All right, 45 divided by 15 is 3, and 75 divided by 15 is 5. All right, and once again, I really and truly don't mind if you use your calculator. I just don't think it's necessary. All right, and you should try to practice. And like I said, I don't care. All right, because the most important part is, do you understand how to reduce the variables? Because you can't really use a calculator for the variables. All right, so now let's look at 20. All right, now again, 25 over 20. I always tell kids, reduce the numbers first. All right, reduce the numbers first. So we're going to divide by 5, and then we're going to divide by 4, or by 5 on the bottom, and we get 4. So essentially, just let me write this just to make sure. Divide by 5, divide by 5. Okay? Now here's where we already know how to do this. This is from a previous chapter a long time ago. Remember, there are 6 x's on top. There's 2 x's on the bottom. So if we simplify, there will be 4 x's left on the top. All right, 4 x's left on the top. Now's the time you need to speak up if you're not sure how I got x to the 4th. Because when we reduce, we subtract exponents. 6 minus 2. That's how I got the 4. Okay? You don't divide exponents, you subtract them.
Oh.
All right. That's like I said, that's just a review. I'm comfortable with these. I think everybody should know how to do 20 through 25. However, it's been a while, so I can understand you may have forgotten. All right, but the rule with exponents are, remember, when you divide, you subtract, and then if you ever multiply, you add. That was the rule for exponents. Okay? So let's look at 22. All right. 18 over 22, or 18 over 24, looks like I can divide by 6, right? Divide by 6, divide by 6. So I always like to make a fraction bar. And then 3/4. Now remember, there's 2 A's on top and 4 on the bottom. Here's where kids make a mistake. That leaves me with 2 A's on the bottom, right? 2 A's on the bottom. Remember, it was like, here's how I showed you previously. A times A over A times A times A times A. And then I showed you that this A divided by that A cancels. So that's why we say there's 1 over A squared. All right, everybody remember that? And then of course the B cubes cancel out. Okay, so that's your answer for 22. That's how easy. Anybody have any issues? Any issues? Again, guys, I so appreciate your work for the most part. Some of you guys are continuously working hard. All right, and now's the time you got to speak up. All right, because it affects the multiplying, it affects the dividing, the adding and subtracting if you don't know what I'm doing. All right, so let's take a look at 24 now. All right, obviously the 2 negatives don't matter. So then we divide by 5 and divide by 5. So I have fraction bar. 15 divided by 5 is 3. 20 divided by 5 is 4. Now I have 3 x's on top and 1 on the bottom, which leaves me x squared on the top. Y cubed over y squared leaves me y to the 1st on the top. Now again, remember, y to the 1st, it's not necessary that I put the 1 there, all right? But I'm just showing you 3 minus 2 is 1. So if I wanted to, you could just say 3x squared y over 4. I like to put the 1 there so it shows that I did the subtraction. Okay? Let's see what's next. All right, 26. All right, so here we go again on number 26. Making a fraction bar. All right. Now, 52 and 39 both have a factor of 13. So I'm going to divide by 13. I'm going to divide by 13. 52 divided by 13, negative 4. And 39 divided by 13 is 3. Now you look at the p to the 5th and p to the 3rd makes p squared on top. And then we're going to look at q cubed and q to the 5th. That's going to leave me q squared on the bottom. And then, of course, if we look carefully, the r squareds cancel. All right, that's really simple, simple, simple. That's how easy it is. All right, any questions? All right, because we're going to change gears now. Everybody's happy. All right, guys, I appreciate it again. Okay, now we're going to look at 28. All right, so what I want to do now is I just want you to, everybody stop and listen for a second. The biggest mistake kids make is they start crossing out here, they cross out here, right? The problem is when you're bounded by addition and subtraction, you cannot cross out. The reason up here we could simplify was because everything was bounded with multiplication. So when things are held together by multiplication, you can reduce. When things are held together by addition and subtraction, you cannot reduce them. All right, you cannot reduce them. All right, so how do we simplify? It's called, you have to factor first, okay? Now, if you're good at factoring, this is the easiest thing in the world. If you're horrible at factoring, this is a nightmare, all right? That's why we spent some time last week and the week before reviewing your factoring, okay? If you reviewed your factoring properly, this is gonna be easy, okay? So what do I mean by that? I want everybody to look at 28. We're going to factor x squared minus 25. So you should be able to, at this point in time, say that's the difference of squares. So that was x plus 5 and x minus 5. Now, if you see on the bottom, there is a common 3. So I'm going to do 3 parentheses x minus 5. Okay? Now what I'm trying to show you is these two problems now, the x plus 5 and the x minus 5 are held together with multiplication, and the 3 and the x minus 5 are also held together by multiplication. Since they're bounded by multiplication, we now can cross out the x minus 5s. Cross out the x minus 5. That's how you reduce this fraction. So that equals x plus 5 over 3. Okay, so again, all we're doing today from now on all the way down the page is factor, 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 cross out, cross out, cross out. That's all there is to it. Very simple, very simple, if you're good at factoring, okay? So let's take a look at number 30, all right? Now on the top, I want you to write down, if you forgot, the first thing you do is you always look for a GCF. That's the most important thing. Is there something common? Well, in number 30, in the numerator, there's a common 5y. So we have to factor out a 5y. When I factor out a 5y, you should be able to, at this stage of the game, see that that's y minus 2. All right? Now, I wish you would speak up if you forgot how to factor out the GCF. Does anybody need me to review anything on the GCF? Don't be afraid. Go ahead. Anybody?
Can you explain it, please?
Yeah, so remember, there's a common, how I taught you before was there's buckets. In these buckets, there's a common 5 and a common y. Does that make sense?
Yeah.
Right? And I'm pulling out a 5y. When I pull out a 5y, there is a y left in the first bucket. And remember, 10 is 5 times 2. So if you pull out the 5 and you pull out the y, there was only a 2 left. Does that make sense? No? Remember that? Now, the other way you can check your work is just simply say, remultiply. 5y times y is the 5y squared, and 5y times negative 2 is the negative 10y. All right? Now you're factoring a trinomial. There is no GCF. All right, so now you're just factoring y and y. The factors of 6 that make 1, 3 and 2. 3 and 2. I want the middle term to be positive. So if you do the smiley faces, that's 3y and 2y. So this is a positive and this is a negative. All right. Now you're supposed to go back and look at the fraction and say, well, that's nice because this y minus 2 and this y minus 2 will cancel. And so you're left with 5y over y plus 3. All right. So every single fraction, two things will be common. You cross them out. That's essentially what's going on. All right. Issues with number 30. Anybody have any issues with 30? All right, here we go. Let's look at 32. All right. Now, here's what I want everybody to make sure that you're okay with. All right. I always try to teach kids, do the easy factoring first. So in my opinion, the 4m squared minus 9 is the easiest to factor because it's the difference of squares. All right. So what I want you to do is we just open up the parentheses and we know it's going to be 2m plus 3 and minus 3. Okay. Now, because I know that we're going to be crossing things out, because I know that one of these factors up top here is either going to be 2m plus 3 or it's going to be 2m minus 3. Does everybody agree with that? All right, now the reason I'm showing you this is because I'm trying to show you how if you do it this way, you can factor much easier, okay? So with that in mind, I know it's going to be 2m and m, right? Now I'm not sure if it's supposed to be 3 or negative 3, so I'm just going to put a 3 here. And then the other way to make 21 is with a 7. And now I'm just trying to make a positive 11. So again, 2m times 7 is 14, and 3 times 1 is 3. So the only way to make positive 11 is if the 14 is positive. If the 14 is positive, and notice this is how I get the 14, and the 3 is negative. So there you have it. All right. So please take a look at that again. I just tried to refresh you on how to factor. All right. Very important. Next year, when you go to class, you should know how to factor. All right. Now, what do we do? All right. What we're going to do now is the 2m minus 3. The 2m minus 3 can cancel. All right. Which leads us with m plus 7 over 2m plus 3. All right, guys. Any issues? All right, continue on. 34. All right. Now, for 34, again, the numerator, you should be able to look at that and say, that's the difference of squares. All right, so that's an easy one to factor. All right, so we'll start with that. 2 sets of parentheses. Now this time, don't forget there's a variable on both ends. All right, because there's a variable on both ends, you got to put a variable on both ends of the parentheses. It's going to be a plus 3b and a minus 3b. All right, which means on the bottom, it's either a plus 3b or a minus 3b. All right, which we now can figure out that it's going to be a plus 3b because these are both plus. So the factor is a plus 3b. All right, now I'm going to put the a here because there's only one way to make a squared. And now with 15b squared, that's going to be a positive 5b. All right, now let's review the factoring again. This multiplied together is 3ab. This multiplied together is 5ab. And if we add them, you get 8ab, which is what this middle term is. All right. And now, as I was trying to show you earlier, the a plus 3b and the a plus 3b cross out. So I have a minus 3b over a plus 5b. All right, does anybody have any questions with that? Sneaky and tricky if you're not careful. All right, let's move on. All right, 36. Here we go. All right. Now, again, we'll start off with the numerator. So we have, always start with the middle factors, 3x and 2x. And now the only factors of 2 are 2 and 1. So I want to write a 2 here and say we know it can't go there because it will have a common factor with this 2. So I know the 2 has to come over here, and I know the 1 has to come over here. Now let's do the smiley face, 4 and 3. All right. So I know the only way I can make -1 is if the 4 is negative and the 3 is positive. All right. So now I'm really trying to teach you something that will help you. All right. I am confident that the denominator is going to have a 3x minus 2 in it. All right. How do I know that? Because I'm trying to reduce. All right. And there's no way from 3x squared to make 2x. So I'm confident that my factoring down here, watch how easy this is if you know that. All right, so I'm going to put 3x minus 2 here. And then the only way to make x squared is if this were x. And the only way to make positive 2 is if this is -1. So again, let me explain that. So if I do 3x times x, that's the 3x squared. If I do the -2 times the -1, that's the positive 2. And then we do our smiley faces. -2 minus 3 is -5. All right, does everybody understand that? All right, now what's nice? 3x minus 2, 3x minus 2 cancel out. So I'm left with 2x plus 1 over x minus 1. All right, everybody good with that? All right, so now on 37, listen, this really is an Algebra 2 topic, okay? It's an Algebra 2 topic. I did not teach you how to factor perfect cubes. All right, so we're not gonna do that. So I want everybody, you can put omit or cross out if you want. 37, and then 38 down here, if you highlight that, that's a perfect cube. Again, that's Algebra 2. Okay, so those are the 2 questions that I think they got a little bit ahead of themselves on. All right, I did not show you how to do the factoring cubes. So we do not have to do 37 and 38. Okay, now let's knock out 40. All right, now on 40, I need you to be real careful because this is to the 4th power. Okay, so we're going to factor that. Okay, so to factor that, we're going to go parentheses, and then that would be c squared plus 4 and c squared minus 4. Now I want everybody to take and highlight c squared plus 4, right? That you does not factor again. However, c squared minus 4 you can factor. All right, so this is a rare case where you have to factor twice. Okay, so I'm going to put an equal here, and then I'm going to leave it c squared plus 4, and then c plus 2, and then c minus 2. Okay, so the c squared minus 4 factored to c plus 2 and c minus 2. All right, and again, c squared plus 4 we couldn't factor. All right, so now we're going to take the denominator, and that's going to factor And it's going to factor to either C plus 2 or C minus 2. C, C, and it's going to be plus 2 and minus 5 because I want the middle term to be negative 3. So if you want to double check, 2 minus 5 is negative 3. All right, so now what we do is we come over here and we say C plus 2 cancels. I'm left with C squared plus 4, C minus 2 over C minus 5. All right. Anybody have any questions with that? And of course, we could put that in parentheses. Anybody have any questions? Anybody have any questions? All right, here we go. 42. We're almost done, guys. All right, so on question 42 now. All right, sorry. We need to recognize that there are 4 terms. So when you factor something that has 4 terms, we factor by grouping. We factor by grouping. All right, so what was common in the first set of parentheses? There was a common C. All right. Then when you pull that out, you're left with D minus 3. Now there's a common positive 5. When you pull out a positive 5, again, you're left with D minus 3. Now the last thing is to recognize this. D minus 3 and D minus 3 is common. So you pull out the D minus 3 and you're left with C plus 5. All right. Anybody have any questions with that? Factoring by grouping. All right. Remember, you factor by grouping when you see 4 terms. Right. Now on the bottom, obviously, I'm looking here and I know it's going to be D minus 3 because we're talking about reducing. And so I know the other one is D minus 4. Now what happens? The D minus 3's cancel. Final answer, C plus 5 over D minus 4. Anybody have any questions? All right, so let's do another factoring by grouping. Hold on a second. Yeah, 44, sorry. All right, good for us. Factoring by grouping here, and a factoring by grouping here. Now remember, GCF, all right? So there's a common Y in here. So I pull out the Y. You're left with Y minus 5. All right, now the tricky part here, I have to get you to remember when the leading term is negative, you have to factor out that negative. So there's a negative 3 common. So when I pull out a negative 3, you end up with Y, and now not positive, but what? Negative 5. All right, and if you want to check me, it would just be negative 3 times Y, which is that negative 3Y, and then negative 3 times that negative 5, which gives you that positive 15. Plus the fact that you want these to always be the same, all right, or it doesn't work. All right, so there is a common Y minus 5 and Y minus 3, okay? Now, of course, one on the top, one on the bottom. All right, they're gonna cancel. I already know the one on the top is gonna be Y minus 5. Once again, how did I know that? Because there is no 3 in 35. All right, that's how I knew that. All right, that's what I'm hoping everybody can see, which will make it a much easier process. Then here, it's Y. The way to make 35 with 5 is a positive 7. All right, and then we just do what? Cross out y minus 5. You're left with y plus 7 over y minus 3. All right, any questions, guys? Everybody's kind of quiet, so I appreciate it. But I also want you to make sure that you're asking me questions. Anybody have any questions? All right, so here we go. Let's take a look at 46. All right, number 46 is important, all right? And I want to start out by saying this. All right, if I said to you 3 minus 7 over 7 minus 3, negative 4 over 4 equals negative 1. All right, so I'm going to try it again. If I said 8 minus 1 over 1 minus 8, 7 over negative 7. So again, that's negative 1. So what I'm trying to refresh your memory on is this. When you have 3 minus 7, when they're written in reverse order, it's always equal to negative 1. All right. 8 minus 1, 1 minus 8 comes out to be negative 1. So if I said to you 3 minus y over y minus 3, you would say that is negative 1. All right. And again, we talked about that, you know, when we were reducing earlier. But again, anytime you have 3 minus y, if the subtraction is written backwards, it's negative 1. Now, if I say x plus 3 over 3 plus x, obviously those are the same, so it's positive 1, right? 2x plus 4 over 4x. Sorry about that. 2x plus 4 over 4 plus 2x. They're the same, so it's 1. All right. But when subtraction is in reverse order, it's negative 1. All right. And that's what's going to happen here. All right. So what I want to do is I want to look at this and say the top I factor into 5 times x minus 4. And now the bottom, we just can't write x squared minus 16. All right. We got to factor it the way it is. 4 plus x and 4 minus x. So what happens? I have now the x minus 4 and the, sorry about that, and the 4 minus x. That cancels to negative 1. So my answer here for 46 is just negative 5 over 4 plus x. Now, traditionally we write the variable in front if we can. So we could write this as x plus 4, but it doesn't really matter. Okay? Anybody have any questions? All right, thanks guys for listening. We got one more to go. Call it a day. All right, now on 48, again, the bottom is the easiest to factor, difference of squares. So that would be 3 plus x and 3 minus x. Now on the top, all right, we have 2x and x, and I want 7. So I know 3 is going to go there, and I know 1's going to go there. Because again, I was looking at the 3 minus x and the 3 plus x. Now I want negative 7, so that's negative, and that's negative, right? Then I can look at this and I can say the x minus 3, 3 minus x, that cancels to a negative 1. So I just put that in front. So I have negative 1, parentheses, 2x minus 1 over 3 plus x. Now, if you want, you could distribute the negative 1, but we generally do not do that. But I do like to put the variable first. So either one of these is correct. And I believe that's it. Okay, so that was, took us a little bit longer than normal. All right, but again, it's just reducing fractions. Now, part of the reasons why I did the evens today is because I did the odds with the other algebra class. So if you're struggling at all, both recordings of odds and evens are available. All right. So there's no excuse. All right. If anybody has a question, I'm willing to go over anything with you right now. All right. If you understand what I did and you don't need any further explanations, the odds are due next class period. All right. So just turn them in next class period. All right. If you feel comfortable, right, I'm not going to post the solutions because there's a video. All right. Go listen to the video if you're having some trouble. If there's one or two questions, you can contact me personally, make a note, say, hey, can you just help me out with this one? I'll be happy to do that. All right. But I do want you to go through and try to do the odds. All right. And then turn that in by next class period. Guys, it's really important for those of you guys, like I said, who are taking entrance exams, you got to be ready. Okay. And this is part of doing well on their entrance exam. All right. So if you don't have any other questions, you're free to go. And then if you want to stay and wait for a second and you want me to answer a personal question, I can be happy to do that. All right. You guys have a great day. Hopefully the restrictions are being lifted, so we'll be able to get out and about soon.
Hi, Mr. Shaw. Thank you.
You're welcome, guys. Have a great day. I appreciate you guys.
Bye.
Bye-bye. Bye-bye. No questions? Ian? Jack?